Welcome to the deep dive. Today we're going deep underground, to those reservoirs that hold oil and gas and even CO2.
Yeah.
And looking at how machine learning is changing things. We've got this great 2023 research paper as our guide.
Hey, cool.
By the end of this deep dive, you'll get why everyone's so excited about EI making this whole process faster, cheaper,
Great.
Maybe even giving us new insights.
Yeah, definitely. It's a really exciting field right now. We're on the edge of some big breakthroughs that could really shake things up for like oil and gas production and carbon sequestration, those kinds of industries.
That's exactly what I want to dig into.
Yeah.
But first, I think we should make sure everyone's on the same page. Can you just give us like a super quick reservoir simulation 101?
Yeah.
What's the goal here?
So imagine you've got this crazy complex 3D puzzle underground, right?
Yeah.
You've got different kinds of rock, different pressures and temperatures, and then fluids like oil, gas, water. All jumbled together, interacting in all these ways.
Yeah.
Reservoir simulation is basically trying to build a virtual copy of this puzzle
Okay.
using physics and math to predict how those fluids will move over time.
So like a giant underground game of Tetris, right?
Yeah, that's a great way to think about it.
But with like real world consequences.
Yeah, exactly.
We got to figure out how to make the pieces move the right way.
And the reason this is so important is it drives those big decisions. Where do we drill new wells?
Right.
How much oil can we actually get out? Will that CO2 storage site hold the carbon safely?
Right.
These simulations are what help us answer those questions.
Okay, that makes sense. But I'm guessing you can't just run these on your laptop, right?
You are correct.
Yeah.
They're incredibly demanding computationally.
Yeah.
We're talking about solving these huge equations that just need massive processing power and time.
Wow.
A single simulation could take days or even weeks sometimes to run.
Wow, had no idea.
Yeah.
So is that where machine learning comes in then? It's like our secret weapon to speed things up?
Yeah, think of it as a shortcut.
Okay.
Instead of solving all those equations, it can analyze all this data, from past simulations, geological surveys, production history,
Right.
to find patterns and relationships.
Okay.
It's like we're teaching a computer to recognize the fingerprint of a good reservoir.
I like that, a fingerprint.
Yeah.
But you said shortcut.
Right.
Does that mean we're sacrificing accuracy?
Not necessarily.
Okay.
There are different machine learning approaches, Some are all about replacing the really time-consuming parts of the traditional simulation with faster AI models.
Okay.
Like imagine a team of super efficient assistants doing some of the heavy lifting for us.
I like that.
These are called surrogate reservoir models, or SRMs.
SRMs,
Yeah.
got it. So they like take on some of the work.
Exactly.
But we're still getting good results.
Yeah, and there's this other really interesting tactic that focuses on fluid properties.
Okay.
Imagine trying to simulate how oil, gas, and water mix together under pressure. Well, that needs us to calculate something called K-values,
Okay.
which tell us how these fluids will act at different temperatures.
So K-values are like
Yeah.
the secret ingredient in our recipe?
Exactly.
Okay.
The problem is traditionally calculating those K-values takes forever.
Yeah.
And tons of computer power.
Right.
It's like a huge bottleneck.
Yeah.
But that's where AI can step in.
Okay.
Machine learning can predict these K-values almost instantly,
Wow.
which makes the whole simulation so much faster.
Wow. That's got to be a huge advantage.
Yeah, especially for like enhanced oil recovery,
Right.
where those fluid properties are crucial.
Yeah, speaking of EOR, is that one of the places where we're already using these new techniques?
Absolutely. Simulating CO2 injection for EOR needs those K-values.
Right.
And the speed boost from AI just makes it so much more doable.
This is fascinating. We've talked about how AI can speed up those individual simulations, but the research paper also talks about history matching.
Yeah.
Can you explain what that is?
Sure. History matching is all about making sure those simulations actually reflect reality.
Okay.
It's like a reality check for our virtual models.
Okay, so we build our simulation, and then we have to make sure it matches what really happened in the oil field.
Right.
Like calibrating our instruments or something.
That's a great analogy.
Okay.
We compare the simulation output to the historical data, like pressure readings, production rates, things like that.
Okay.
And if they don't match up, we have to go back and tweak things in the simulation, run it again, compare, tweak again.
Oh, wow. That sounds tedious.
It can be, yeah.
I bet it takes forever to get a good match, especially for a complex reservoir.
Especially for a complex reservoir.
And
Yeah.
so is that where AI comes in to simplify things?
You got it.
Okay.
Instead of tweaking those parameters by hand, we can use machine learning to analyze tons of data and suggest adjustments that'll give us a better match.
So like an AI detective
Yeah.
piecing together clues to get a more accurate picture of what's happening underground.
Exactly. And it's not just about matching the past.
Okay.
AI is opening up new ways to actually discover new insights about the reservoirs.
Okay, cool.
Like the paper talks about deep learning,
Mm-hmm.
which is a super powerful type of AI that can analyze massive data sets and find those really subtle patterns that we might miss.
Okay.
Yeah.
Deep learning, that sounds intense. Is that like AI with a PhD in geology or something?
Haha. You could say that, yeah, it uses these really complex neural networks,
Okay.
basically layers and layers of algorithms that can go through massive amounts of data,
Yeah.
like seismic images, well, logs, production data,
Okay.
and pull out insights that humans probably never find.
So it's not just crunching numbers anymore. It's
Yeah.
like the AI is actually developing an intuition about how the reservoir works.
Exactly. Deep learning can go beyond just history matching
Okay.
and start to predict things like the best spots for new wells,
Mm-hmm.
potential problems that might pop up during production,
Yeah.
or even find hidden pockets of oil and gas that we missed with the old methods.
Okay, now we're talking, this is like the cutting edge of reservoir science.
Yeah, it is.
And speaking of cutting edge, our research paper mentioned some specific types of deep learning networks that are working really well. Can you break those down for us?
Sure, one type is called recurrent neural networks, or RNNs.
RNNs.
Yeah, they're really good at analyzing data that changes over time,
Okay.
like production rates or pressure readings.
So RNNs are like the time travelers of the deep learning world.
Haha, I like them.
Spotting those long-term trends that we might not see.
Exactly.
Cool. Then we have convolutional neural networks, or CNNs.
Yeah, CNNs, you've probably heard of those.
Oh, yeah, CNNs.
They're the brains behind a lot of image recognition technology.
Right, some of those apps that can tell you what kind of dog you have just from a picture.
Exactly.
I never thought they'd be used for something as complex as reservoir modeling.
Well, it turns out they're awesome for analyzing 3D seismic data,
Okay.
which is kind of like an X-ray of what's underground.
Right.
CNNs can pick out these tiny geological features,
Mm-hmm.
like faults and fractures that could indicate oil and gas
Okay.
or potential risks.
So CNNs are giving us superhuman vision to see what's hidden down there.
Yeah, pretty much.
I'm starting to get how powerful these tools are.
Yeah.
But the paper also mentioned generative adversarial networks, or GANs.
Yeah, GAMs, those are...
That one sounds a bit more mysterious.
They're definitely one of the weirder concepts in deep learning.
Okay.
It's actually two neural networks working together.
Okay.
It's kind of like a game of cat and mouse.
A cat and mouse game. Okay, how does that work?
So imagine one network, the generator, is trying to create fake reservoir data,
Okay.
like a pretend seismic image or a well log.
Uh-huh.
It's learning from the real data and trying to copy it perfectly.
So like a digital artist trying to forge the Mona Lisa?
Haha, yeah, a perfect analogy.
Okay.
And then the second network, the discriminator, is like the art critic.
Mm-hmm.
Its job is to spot the difference between the real data and the fakes.
So it's trying to catch the forgeries.
Exactly, and here's the cool part.
Okay.
As the generator makes better fakes, the discriminator has to get smarter to catch them.
Right.
This back and forth actually makes both networks better.
Okay, so they're both learning from each other.
Yeah, it's like a competition that pushes them both to improve.
Okay, that's cool, but what does this AI art competition have to do with reservoir modeling?
Right, so GANs are really good at exploring all the possible ways a reservoir can be configured.
Okay.
They can help us brainstorm new ideas, find scenarios we hadn't thought of,
Yeah.
and even generate synthetic data to fill in gaps where we don't have enough real information.
So with GANs, we could have AI brainstorming new reservoir designs, coming up with ideas we never even considered.
Exactly.
That could change everything for finding more oil or storing CO2 better.
That's the power of these deep learning techniques.
Yeah.
They're opening up a whole new world of possibilities for how we understand and manage these resources.
This is all so exciting. It sounds like the future of reservoir simulation is going to be wild.
It is.
But I'm also curious about the challenges. What
Yeah.
are some of the limitations we need to be aware of as we go further into this AI-powered world?
That's a great question. One of the biggest challenges, like with most AI, is data quality.
Okay.
These models are only as good as the data we feed them.
Garbage in, garbage out, right?
Exactly. If we have bad data, the results won't be reliable.
Right, so data is key. Are there any other hurdles?
Another challenge, especially with deep learning, is what we call the black box problem.
Okay.
These models could be so complex that it's hard to understand why they're making certain predictions.
I could see how that would be a problem.
Yeah,
Especially when you're making big decisions about where to drill or how to manage a CO2 storage site.
exactly. We need to find ways to make these models more transparent so we can understand what's going on inside.
Right. Otherwise, it's hard to trust them.
Yeah, for sure.
Okay, so data quality and transparency are key. What about the human element?
Right.
Are reservoir engineers going to be replaced by robots anytime soon?
Not at all.
Okay, good.
These tools are meant to help human experts, not replace them.
Okay.
The real power comes from combining the engineer's experience with the analytical skills of AI.
So it's not man versus machine.
No.
It's man plus machine.
Exactly. It's about giving those engineers new tools and insights
Right.
so they can make better, faster, more informed decisions.
Yeah.
And that's where I see the most potential,
Mm-hmm.
but also the biggest challenges.
Speaking of challenges, our research paper also talks about how the industry is actually using these new technologies. It seems like everyone's talking about AI and oil and gas, but are companies really using these tools?
That's a really good question, and one the industry is still figuring out.
Okay.
There's definitely a lot of interest and excitement,
Yeah.
but putting it into practice is still a bit limited.
Really? That's surprising why the hesitation. It seems like the benefits are huge.
Well, the oil and gas industry is, by nature, pretty risk-averse.
Right.
These companies are making huge investments.
Mm-hmm.
They need to be sure that any new technology will actually work.
Yeah, you don't want to bet billions of dollars on an algorithm you don't trust.
Exactly. And then there's the human side of things.
Okay.
Reservoir engineers have years of experience,
Right.
their own methods and workflows.
Mm.
It's not easy to suddenly switch to a whole new way of doing things.
Yeah, even if it's AI powered.
Even if it's AI powered, right?
I imagine there's a learning curve for everyone involved.
There is. Yeah, both for the engineers and the companies using these tools.
Right.
It's not just about learning how to use the software.
Mm-hmm.
It's about understanding those AI algorithms and what they can and can't do.
So you need someone who understands both the AI side and the reservoir engineering side.
You need someone who can bridge that gap.
That's a tall order. Where are these experts going to come from?
I think it'll take a few different approaches.
Okay.
Universities are starting to offer programs in data science for the energy industry.
Okay.
And companies are training their current employees.
So we need to upskill the next generation of engineers and bring the current workforce up to speed.
Exactly. It's a big task.
Oh, yeah.
But I think the industry is starting to see how important this is.
Okay.
They're realizing that AI is not just a fad.
Hmm.
It's a fundamental change in how we'll manage these resources in the future.
That's a great point, and it leads us perfectly to the final part of our deep dive, where
Okay.
we'll explore the future of this field.
Sounds good?
What's the long-term outlook for AI in reservoir simulation?
Yeah.
What are the big things we should be watching for?
It's an exciting time to be in this field, let me tell you.
Okay.
A combination of powerful AI techniques, increasing computer power, and all this data we're collecting,
Yeah.
it's creating a perfect storm for innovation.
Okay, you got me intrigued. What are some of the things you're most excited about?
One area that's really heating up is using AI for, like, real-time reservoir management.
Real time.
Yeah, like, imagine being able to constantly monitor and tweak production,
Okay.
almost like having an autopilot for your oil field.
Wow, that sounds incredible.
Yeah.
So like an AI co-pilot helping you make those decisions on the fly.
Exactly.
How would that actually work?
So sensors and data systems are getting so much better.
Mm-hmm.
They give us a constant stream of information about what's happening down in the... Well,
Okay.
AI can then analyze that data in real time
Right.
to find patterns, predict problems,
Mm-hmm.
and even suggest changes to optimize production or injection rates.
So it's like an AI brain constantly watching the reservoir's vital signs.
Exactly.
And making sure everything's running smoothly.
And this real-time capability is huge
Yep.
for efficiency, safety, environmental performance.
Right.
We could avoid those costly shutdowns, reduce the risk of accidents,
Mm-hmm.
and even minimize our environmental impact.
That's a triple one.
Yeah,
It sounds like AI could completely change how we manage these complex systems.
for sure.
Any other big trends we should be watching?
Another really interesting area is the development of hybrid models.
Hybrid models.
Yeah.
So we're not choosing between physics and AI. We're blending them together.
Exactly, combining the best of both worlds.
Okay, tell me more about that.
So think about it this way. Traditional simulators are great at capturing the physics,
Mm-hmm.
but they can be slow and struggle with uncertainty.
Right.
AI is awesome at finding patterns and dealing with huge data sets, but it can sometimes lack that rigorous physics foundation.
Okay, so it's like having a team of engineers working with a team of data scientists.
Exactly, each bringing their own strengths.
Cool.
By combining those approaches, we can create models that are both accurate and fast. They handle uncertainty, better use real-time data more effectively,
Yeah.
and can even give us insights that neither approach could on its own.
So the future of reservoir simulation is all about collaboration then.
I think so, yeah.
Between different fields and between humans and machines.
Absolutely.
This has been a mind-blowing deep dive into AI and reservoir simulation.
It has been, yeah.
I feel like I've seen a glimpse of the future of this whole field.
Me too.
Before we go, is there a key takeaway you want to leave our listeners with?
The biggest thing, I think, is that AI is not just hype in the oil and gas industry.
Right.
It's a game changer that could completely transform how we find, develop, and manage these resources.
Yeah.
The future's wide open.
And it sounds like we're just getting started.
Oh, yeah. Just the beginning.
But as AI keeps getting better, we can expect even more amazing breakthroughs in the years to come.
Definitely.
Maybe AI will even help us unlock the full potential of these underground resources.
I hope so.
Leading to new discoveries and a more sustainable energy future.
Absolutely. The deep dive continues.
Thanks for joining us on the deep dive.
Yeah, thanks, everyone.
We hope you enjoyed exploring the world of AI in reservoir simulation. Until next time, keep learning and keep exploring.